This is Holy Cross, component 1 mock, and this is mock number 1. We're on to question 2, and we've got a graph. And this is about populations, a little bit of microbiology, and we've got the growth of yeast. We know about yeast, and we've got later on we've got another fungus growing, penicillium. Calculate the mean production of yeast cells between 2 and 10 hours. Right, there's a little trap here, I'm afraid. With a ruler this would help, but the trap is that these points that are on here aren't necessarily tying up with the hours. So what we want to find out is how much has been produced per hour. So how much has been produced in 8 hours and divided by 8. So here's 2. So we are going up there from 2. And that sort of thing there. And then at 10 we can do the same. You could do this, you could do this just by looking at the graph, but I'm just doing it to make the point. And so each square here is worth 0.2, so 0.246, that, yeah. So this number here is about 1.3, and this is 6.2. And here, what was the time between there? We got 8 hours. So it's gone up by how much? 6.2 minus 1.3. So it's gone up 4.9 in 8 hours. So let's just, so mass of yeast, mass of yeast cells, from 1.3 to 6.2. So the difference is 6.2 minus 1.3 equals 4.9. Time elapsed is 8 hours. So the calculation is 4.9 divided by 8. So 4.9 divided by 8 is 0.6125, and we'll round it off to something sensible like 0.61. 0.61, and it's given us the units there, so we don't need to add any more units. So sorry, a little trick there on the graph. 2 possible reasons for the change in multiplication of cells between 12 and 14 hours. So here, so you should recognize the stages of this, the lag phase, the log or exponential phase, stationary, and then actually this stage here is the kind of death stage at the end. So it says reasons, so not name the stage. So reasons, well, we must have used up our nutrients. That's probably the main reason, that we've run out of food to grow yeast. But also this ethanol is a toxic product, so you know that sometimes toxins are produced when cell density gets very high. So this ethanol is actually poisonous to the yeast as well. So these are our 2 answers here. So nutrients used up, and that's kind of like our limiting factor, and ethanol may be toxic to the cells. Describe fully the relationship between the growth of the yeast and the yield of the ethanol. So that is comparing the yeast line with the ethanol line. So we're using words like, both do this, but one of them might do something and the others, a bit different. That sort of language. So they look, kind of sigmoidal, don't they? They both look pretty similar. So I'm going to mention that. So both have similar curves, or the rate of production follows the rate of growth of yeast. Can we put any numbers on here or justify that in any way? Well, when do they reach a maximum, for example? So they reach a maximum at about there. So that's 8, 9, 10. It's about halfway between 9 and 10. So they both reach their maximum at 9.5 hours. So both reach a maximum at 9.5 hours. Or you could say, or at the same point. What else could we say? During the start, this lag phase, production is low, something like that. We're just trying to just give some numbers and points relating to what you know about these different sort of phases. So during the lag phase, I can't spell slow. Slow growth and low production. Those sorts of things. So I'm making some comparisons, and if you've made another valid comparison, then you might have been given them out there. What could have been done at 10 hours to increase the growth rate? Well, we suggested that nutrients have been used up, so if we gave it some more nutrients, it might grow more. So give it some more sugars or something like that. So add a sugar such as glucose. That's the most obvious thing to say. We could counter this ethanol being toxic argument. We could say, well, if it's toxic, we could dilute it or remove the ethanol or something like that. But the most obvious, go for the most obvious thing. Adding more food. Here's another graph, and you should also recognise this graph. This is in your notes. The production of penicillin by Penicillium. And much the same axes. You can see this is bigger numbers there, similar numbers up the left. Let's take 3 ways in which the pattern is different. Okay. So, well, one straight away with this curve, this growth curve of the fungus, it's very slow compared to our yeast. So we could say that Penicillium, name of this one. So this is our fungus, Penicillium, grows more slowly than the yeast. So there's a general point, and our product penicillin. So our product penicillin, well, at the start we don't have any at all, as opposed to our ethanol, which is starting with the growth of yeast. So this area, no penicillin being made. So at the start, no penicillin produced. Or we could actually give this number here, which is so it's 5, it's 20, and so each one of these is 4. So 4, 8, 12, 16. So at start, no penicillin produced until 16 hours. And then what happens at the end? Well, even though the growth of the fungus levels off, the production of penicillin is still going up, as opposed to this other graph where both were going down. So, you know, during the stationary phase, penicillin continues to be produced, you know, at a fast rate. That yeah, in some sort of way of describing it, it's still going on faster than the growth here, at a fast rate, something like that. So it's not going, production is not going down, or it's at a fast rate, or we could say, you know, it's still increasing. That might be a slightly better way of saying it. And then the last part is why, basically. Why is this accumulation here different to the ethanol being produced there? So this is slightly more difficult. It's okay if you know why this penicillin here is produced. That will give you some help. And really, it's this penicillin is produced when this fungus density, you know, gets too high, and the fungus is producing the penicillin to kill off other microbes such as bacteria. Whereas from your knowledge of respiration, you know that ethanol is just a byproduct of the process in order to kind of recycle NAD. So it's not produced for any particular reason apart from just so we can get our NAD back. So that's why these two curves reflect each other. It's just produced when we have anaerobic respiration. So we just need to put that into words. We can say penicillin is produced, you know, to destroy other organisms, you know, that are competing for the same food source. This happens, you know, when the fungus, you know, is in the kind of stationary phase most, whereas ethanol, you know, just a waste product, you know, from anaerobic respiration. So if there's no glucose or less respiration, you're just going to get less ethanol being produced. And so the marks there, you're getting kind of 2 marks from the penicillin answer, telling us that this is a useful product or why it's produced, and mentioning competition or the phase, that sort of thing. That's what we're looking for. And 14 marks.